Introducing function. So this is a linear function. We have f of x equals to x plus 3. So the f parenthesis x is f of x. All right, so f of x. F is the name of the function. You can call this g of x, k of x, w of x, whatever you like to call, but usually we use f of x. F is the name of the function, and then the x inside the parenthesis, that is called an input. So input in function, we use the word domain. Domain is a place where x lives. And then where is the y? So there is no y. We replace the y with f of x. So let's take a look at the equation. So for function, instead of y, we use f of x. For equation, we will just write y equals to x plus 3. X is an independent variable. Y is a dependent variable because the value of y depends on the value of x. So let's say x equals to 10. So you put a 10 right over here. 10 plus 3, y is equals to 13. So the value of y depends on the value of x. And then when you write a function, we are not using y anymore, we are using f of x, and then f of x is an output. So output is y, which is the range, and then range is a place where y lives. So how does the input and the output work? So I have an example for you. So let's say we have x equals to 1. So when x is equals to 1, we replace the x with 1. And then the math in here is just a 1 plus 3, which is equals to 4. So when you input a value into the function, you get one output. So you input one thing, you insert a number to the function, you will get an output. X is the input, input means domain, and then y is the output, output means the range. And the most important thing that you have to remember is one input gives you one unique output. Let's read this again. One input gives you one unique output. What does that mean? So most of the textbook, they draw this picture. They draw two ellipses, one for domain x and then one for range y. So for the math that we just did, when x is equals to 1, we input 1, and then the output is equals to 4. If you let x equals to 10, then 10 plus 3 is equals to 13. So I would just picture this as like a little machine. So for domain, you input a number to the function, right? It's just like on the domain ellipse, you press a key. Imagine there are many keys inside the domain ellipse. So do you see this ellipse? Imagine that there are many keys inside this ellipse. You have many keys, just like the keyboard. There are many keys. When you press a key on the domain side, a light bulb lights up on the range side. Once again, you have many keys in the domain ellipse, and you have many light bulbs or lights in the range ellipse. So when you press a key in the domain side, a light bulb lights up. Right? So when you press a different key, for example 10, a different light bulb lights up. So every time you press a key, one key, every time you press a key inside the domain, you get one output, you get one light in the range. Once again, one input gives you one unique, all right, unique output. Whenever you press one key in the domain, you get one light in the range. So one key, you get one light. You press another key, then you get something else. But every time you press one key, you get one light only. One. You press one key, you get one light. All right? And then what is the relationship between the domain ellipse and the range ellipse? The relationship is to describe the x and y, that is f of x. So to describe the relationship between x and y, or x and f of x, the relationship is x plus 3. Right? So the description of the function is x plus 3. What description? Another way to picture the function is, imagine that function is a machine. So you have a machine, and then inside the machine you have x plus 3. So it's like some parts in a machine. You have x plus 3. So whenever you input something into the machine, you get one output. Just like a vending machine. You put money in the machine, you press a key, you get your drink. All right, so when x is equals to, let's say x equals to 5, then you input a 5 to the machine, and then inside the machine, they will do 5 plus 3 equals to 8, and the 8 pops out of the machine. If you input x equals to 20, you insert 20 into the machine, 20 plus 3 is equals to 23, so 23 pops out on this side. So one input gives you one unique output. So when you do the input and output thing, when you input a number to the function, you do the calculation, you try to get an output, we call this a function evaluation. So let's practice function evaluation a little bit. I have a function f of x equals to negative x squared plus 3x plus 1. I want to evaluate all of them. So the first one is f of 0. When x is equals to 0, you have negative 0 squared plus 3 times 0 minus 1. So the output is equals to negative 1. Simple, right? When x is equals to negative 2, you have negative 2 squared plus 3 times negative 2 minus 1. What do you get? You get a negative 4 minus 6 minus 1. Then you get a negative 11. All right, how about 3? When x is equals to 3, so f of 3, you have negative 3 squared plus 3 times 3 minus 1. This is a negative 9 plus 9, which is 0. 0 minus 1, you get a negative 1. All right, and then what else? I have x minus 1. If you replace x with x minus 1, so you have x minus 1, right? And this becomes negative x minus 1 squared plus 3 times x minus 1, and then minus 1. And then you square that out, negative, that becomes x squared minus 2x plus 1, right? And then plus 3x minus 3 minus 1. And then you have negative x squared. And then you will have plus 2x. And then minus 1 plus 3x. Negative 3 minus 1 is negative 4. Then you have negative x squared. 2 plus 3 is 5 plus 5x. Negative 1 minus 4 is 5. Now, you may ask me, hey, you said you press a key on the domain side and then you get 1 light on the range side, right? But if you look carefully, when you let x equals to 0, you get a negative 1. When you let x equals to 3, you also get a negative 1. Is this okay? The answer is absolutely yes. So at this time, so you have a domain, and then you have a range, all right, and then you have a 0, right? And then you also have a negative, you have a 3, but they both give you a 1. So when you input a 0, you get 1 unique output, right? You didn't get 2 light bulbs, you get 1. You get 1 light, not 2 lights. When you press a key, that key is a 0. On the other side, you get 1 light. That is true. But when you press 3, you get 1 as well. But is this okay? The answer is absolutely yes. Because you press 3, you press 1 input, then you get 1 output. You get a 1. But if you say, when I press 3, I got multiple outputs, like 1, 2, 5, 10, then that is bad. There's something bad happen, right? Okay, let's move on to the next function. The next function, I give you something else. This is a rational function. We have a numerator divided by a denominator. So let's evaluate this. G of 0, so we have G of 0, so this is a 2, 0 squared minus 9, then this is a negative 2 over 9, right? And then G of root 4, you have 2. When you square the root 4, that becomes a 4 minus 9, so this is a negative 2 over 5. How about 3? So G of 3, you have 2 divided by 3 squared minus 9. What is 2 divided by 0 equal to? Please don't tell me that is equals to 0. 2 divided by 0 is undefined. How about negative 3? G of negative 3, you have 2 divided by negative 3 squared, 9 minus 9. You have a 2 divided by 0 again. This is also undefined. All right? Please don't say 2 divided by 0 is 0. That is a horrible mistake. So undefined. All right, that is how the function works, and that's how the function evaluation works. All right, so if you like the way I explain math, give me a like, a subscribe, and I will meet you all in the next video. Signing out.